Hi, I'm Adolph Oliver, and this lesson's about combining like terms. Hopefully you recall that the idea of terms are things that are separated by plus and minus signs that are not enclosed in any kind of parens, grouping symbols in general here. So let's give you some examples. I could have negative 3x plus 2y minus 7z, for instance. Okay, these are separators, the minus, the plus, and the minus. None of these are enclosed in any kind of grouping symbols. The minus in front, there's nobody in front of it, so it's not really separating anything. And of course, we want to remember that the sign goes with the guys behind it. So this would be the first term, this would be the second term, and this would be the third term. Now, in this particular expression here, each of the terms has a different variable. So none of these guys are what we're going to call like in a moment. I mean, this could be minus 3 apples, plus 2 oranges, minus 7 lemons, for instance. All different things. Now, what of course happens with terms is that since they're separated by plus and minus signs mean you're adding and subtracting things. So that's what happens. Terms are added and subtracted from each other. But to be able to combine any of these, to add and subtract them directly to each other, they have to be the same type of thing. In other words, apples to apples, oranges to oranges, for instance. Well, that brings us up to officially what do we mean by like terms. Like terms have the same variable in the term raised to the same power. Now, we're only going to look at simple examples in this first encounter with combining like terms, so everything's going to be to the first power, but you want to get used to this. It won't be too long before we'll pop into variables that are being squared and cubed and even higher powers than that. So officially in the long term, like terms have to have the same variables in the term, and each of those variables has to have the same power as it does in the other one. Okay, well, let's give you an example of what we're going to have in this case. I could have, again, minus 3x plus 2y, but then plus 5x and minus 7y. Well, so we've got like terms here in the x's. Okay, x to the first power in both of these, and the y's to the first power in both of these. I can combine directly the x's to each other, and I can combine directly the y's to each other. Well, what happens when we do it on this? One of the things when we combine like terms is we like to have our answer list the variables in alphabetical order. So since x comes before y, I would combine the x's first, and what I have is negative 3 plus 5. Now remember, we're doing positive and negative parts here, but you figure this out in your head. Positive part is 5, negative part is 3. Well, positive wins by 2, so plus 2x. And I don't need to put the plus in front unless I really want to. I mean, you can if you want to, but if you don't see a sign in front of the first part of your answer here, folks would assume it's plus. Now we've got to combine the y's. These are both y to the first power. They're like. So I've got plus 2 and minus 7. Negative wins by 5. So the last part of my answer here is going to be negative 5y. Okay, well, that's what combining like terms is all about. Now, of course, what you do, once you've identified the like terms, is simply what we've worked out up here. You simply go ahead and combine the guys that are like, and remember, of course, that we like to have the answer be in alphabetical order. Now, one of the things that happens is we may have cases where there is more than one sign in front of the term. Then that's where the rules get used to combine those signs down to a single one, and then, of course, we combine like terms. Let me give an example up here. Let's say we have minus, and let's see, plus 3x, and then plus minus 4x, and then minus, let's say 6x. Okay, well, what we have to do first is, since each one of these guys has more than a single sign in front, what we have to do is use the rules to combine the signs. So this minus and plus combine to a minus. So this is minus 3x. The plus and the minus here are also unlike. They combine to a minus, so that's minus 4x. But the two minuses over here combine to a plus, so that's plus 6x. Okay, well now I've got single signs in front of each of the terms. Now I know exactly how much I have of each. These are all like terms. They're all x to the first power here. Remember, if you don't see a power, you assume it to be 1. And what do we got here? The total negative part is 7. Negative 3 and negative 4 give me negative 7. So the negative part is 7. The positive part is 6. Negative wins by 1. So the answer on this, negative 1x, which I could write just as negative x. Remember, if there's not a number in front of the variable, folks will assume it's a 1. You could put the 1 here if you want, but since it's negative, we definitely have to put the minus sign. If you left this off, folks would assume that it was positive. Okay, well, the next thing coming up here is that we can have cases where we've got some parents around these, and what we have to do is use the distributive law to clear these out, then collect the like terms. So we might have something like this. Minus 3x plus 2y plus 4x minus y. Okay, now notice we have more than a single term inside the parents. Now notice what I'm doing here. I can talk this way. If I cover up the parents that are enclosing the 3x plus 2y and pretend that they're not there, then when you look inside, you see two terms there. You see the 3x and the 2y. So we can talk this way. I can say that there are two terms inside the parents. Although, if I turned around and just took a look at everything all told here, let's cover up the second part here. Officially, with those parents in there, that would of course be just a single term, because this separator plus doesn't count now since it's enclosed in parents. So the way it's written here as you're looking at it, they're just a single term. There's nothing in front of this minus to be a separate term over here. But again, if I turn around and play this game and say, well, how many terms are inside the parents, then I can say, well, there are two terms inside. So notice this whole expression, the way the whole thing is written here, is if you take it the way it's exactly written with the parents, there are exactly just two terms, this one guy right here and this second guy here, because the separators inside the parents don't count. But again, I can turn around and say that there are two terms inside this first set of parents, and if I play the same game with the second, I can say there are two terms inside this. Well, let's get back to what we really want to be doing here, and that is combining the like terms. And so what you have to do is, if you've got more than a single term inside parents, notice up here in the previous problem we only had one guy inside, so you could combine the signs directly. But now we've got to take and distribute the signs in. Well, remember that a minus means take the opposite of. And whatever's in front of the parents by the distributive law has to be distributed to both of the guys inside. So we apply the idea that a minus means take the opposite of to the plus 3. Remember, you don't see a sign in front of this 3, so we assume it to be plus inside here. Well, what's the opposite of plus 3? Minus 3. So this one becomes minus 3x. The same thing here. What's the opposite of plus 2y? Well, this becomes minus 2y. Okay, well, we've got to do the same thing on the second guy, but there's a plus in front. Well, we distribute that plus in. Remember what a plus means. Stay where you are. A plus does not cause any changes. So that means whatever signs these guys have inside are going to remain the way they are. So for instance, in front of this 4 here, you don't see a sign, so we assume it to be plus. Well, taking the plus of that, meaning keeping it the way it is, just write that down exactly the way it was, plus 4x, and I'm putting the plus here to emphasize that. And the minus y doesn't change, it remains minus y. Now let's show you what we've done here again. We wanted to find out exactly what the sign and number was in each one of these terms. If you have parens up here with something in front, you have to use the distributive law to figure out exactly what you have before you can combine like terms. Now, very commonly, we'll have numbers along with the signs here, but I wanted to emphasize to you, if you just have a minus sign or a plus sign, it's very easy. The minus simply means in front, take the opposite of everybody that's inside. So plus 3x became negative 3x, plus 2y became negative 2y. But a plus in front means keep everybody the way they are. So plus 4x remained plus 4x, minus y remained minus y. Well, now we can turn around and combine these guys. Notice we've got x terms and y terms, both to the first power here, so we can combine those. Let's see what we have for x. The negative part is 3, the positive part is 4, so positive wins by 1, so there's a single x. Now, I can write that just as an x like this. You could put the 1 in front, and you could put the plus if you wanted to. But if folks do not see the number, they'll assume it's a 1, and if they don't see a sign, they will assume it's plus. So you could just write it as x, and that's a more compact way of doing it. Now, don't forget the y's. I've got negative 2y and negative 1 more. Remember, since we don't see a number here, we assume it to be 1. So negative 2 and negative 1, the total negative part is 3. There's no positive part for the y's, so obviously negative's going to win by the total amount. So we end up with negative 3y. Okay, well, there we are. That's the process of combining like terms in this first time that we're looking at it. Now let's look at some more examples to get the idea down a little better. Okay, here's the first one. Now, notice here we have a single sign in front of both the terms, so we don't need to use the rules at all. I've got negative 2v here and minus 1v here. Remember, you could put a 1 here if you wanted. Let's draw it in just for fun. There it is. So if you don't see a number, you assume it's 1. Well, what do we have for the answer on this one? We have like terms, v to the first power. Negative 2 and negative 1 means the total negative part is 3. There's no positive part, so negative definitely wins. And so we end up with negative 3 of those v's. Okay, let's take a look now at something that's not only got some variables, but some plain numbers. Here we go. Now notice the 4k in front. You don't see a sign in front of it, so we assume that to be a plus. Let's put a plus in here just to emphasize that. All the other guys have single signs in front, so we don't need the rules at all to be able to combine signs. Let's just indicate the like terms. Here's k to the first power. Those guys are like. But the other guys that are like are the plain numbers. What they have is no variable at all, so that makes them like. So plus 3 and minus 4 happen to be like. Okay, well now, we want to combine these, and here's the idea. I mentioned to you when we have letters, we want to put them in alphabetical order. Well, there's only one letter here, so the one and only we do first. The numbers are always relegated to the last position, the pure numbers there at the tail end. So, I've got plus 4k plus another k. Total positive is 5. There's no negative, so obviously positive wins. So this will be 5k. And once again, you could leave the plus sign off if you want. And then we combine the plain numbers. Positive part is 3. Negative part is 4. Negative wins by 1. So negative 1. Okay, well, the same type of thing is going on here. Once again, everybody's got a single sign in front of them. And this n in front, since we don't see a sign, we assume it to be plus, so let me just write it in there to remind us. Now, the like terms, well, the end of the first power are like, and then the plain numbers are like, and the plain numbers, of course, always go at the end. So the first thing we're going to do is combine the ends. Well, I got plus 1 here, plus another one. That's plus 2n. And again, you could leave the plus off if you want. And then combine the numbers, -6 and -8. That's a total of -14. So this is a rather simple and direct problem here. There we've combined the like terms. Now, we of course mentioned that if we have a case where the distributive law plays a role, and that occurs when you have parens with more than one term inside, here it is, there are two terms inside this set of parens, then to know exactly how much of this plain number we have and how many k's we have, the first thing you have to do is distribute this -8 inside. Well, 8 times 3 is 24, and there's one minus sign, so that means this gives me -24, and then we also have to distribute the -8 into the 7. 8 times 7 is 56, there's only a single k, so we have 56k, but notice we have two minuses. Minus and minus can be combined to a plus. So, distributing in here again, -8 times 3 is -24. -8 times -7 will give me positive 56 and k to the first power. Now, in the final answer here, you'll want to turn these guys around because we like to have the variable first. So 56k, remember, you don't have to put the plus if it's the guy in front, can if you want. And then, of course, minus 24. So there would be the optimal way of indicating the answer on that one. Okay, well, here's one like we mentioned earlier here. This really is a distributive law problem again. There's more than one term inside the parens. There are two guys in here, and we have a minus in front. Now, you could always write this as a -1 and distribute a -1 in, but it's easier and quicker just to remember that the minus sign means take the opposite of these, and so we can very quickly just do that. The plus p becomes negative p when we take the opposite of it, and the plus 6 becomes -6. So having a minus in front is very easy to distribute in. Simply take the opposite of everybody inside, and there it is. Now, of course, we could also have a case where the distributive law holds, but we have more than just a single minus or plus. We've got a number with the sign in front. Well, this is regular distributive law once again, and so go ahead and distribute this in. -4 times m is -4m. -4 times -5, well, 5 times 4 is 20, and the two minuses give me a plus, so plus 20. Well, this is actually in the order we want it for the answer. The variables first, so -4m, and the numbers last, plus 20. Okay, well, now that we've had a little practice with that, here's the type of thing we'll be seeing more commonly, where we've got an expression that we want to be able to simplify, and that term simplify, of course, means write it as compactly as you can, and anytime you can collect like terms, that's a process that will make the final answer much more simple. Well, we have distributive law in two cases here. So before we do any collecting, the first thing we have to do is take and distribute the guy in front into each of these to do the distributive law. -7 times 10 is -70. -7 times plus x, well, the plus and minus give me a minus. 7 times x is just what I said, 7x. Okay, let's turn around and do the same thing. Take the -3 and distribute it to both the terms in the second guy. 3 times 3 is 9. There's one minus sign, so this first guy will give me -9. The second guy, 3 times 10 is 30, but there's an x, so I'm going to get 30x, but I have a minus sign from the guy in front and a plus sign here. Minus and plus combine to a minus. So there is what I get in the second guy. Now let's look at these again quickly. Negative 7 times 10 is negative 70. Negative 7 times plus x is negative 7x. Negative 3 times positive 3, this is really a plus 3 inside, gives me negative 9. And negative 3 times plus 10x gives me negative 30x. Okay, well now we've got all the terms with their correct number and sign in front. Now we know exactly how much of each we have, and we can now combine the like terms. Well, we want to combine the variables first, and then we'll combine the plain numbers. So let's see. Negative 7x's and negative 30 more. Well, that's all negative parts, so that's just a total of negative 37x. And then negative 70 and negative 9, well, those are both negative. The total negative is 79. No positive, so the negative wins by 79. So there we are. Okay, well, let's take one last look at this. And again, we'll be seeing things in the future that will have a lot of this in them and require some cleaning up. Here we go. Once again, we've got distributive law cases, somebody in front who can multiply into the guys inside, so we want to find out exactly how many n's and how many plain numbers we have. Well, we've got to use distributive law to get rid of these parens that contain things inside them to be able to do that. So, negative 7 distributed into both of these guys. Negative 7 times n is negative 7n. Negative 7 times negative 5, well, the two minuses combine to a plus, and 7 times 5 is 35. Okay, same thing on the next guy. Here we go. Take the negative 6 and distribute it in. Negative 6 times n is what I just said, negative 6n. 6 times 7 is 42, but the two minuses combine to a plus, so this is plus 42. Okay, well, we're ready now to indicate what the final answer is. We have n to the first power like terms and then plain numbers, which are like. So we want to put the variable first. Negative 7 and negative 6. There's a total of negative 13 here. There's no positive, so the negative wins. Negative 13n. And then the numbers are both positive, so, well, we simply add those together. What do we end up with here? I think 77 when we combine 35 and 42, and it's positive. So there we go. Well, there will be a lot of this type of cleaning up being done in the future, but let me tell you one of the reasons why we do this. Remember, earlier on, somebody would on occasion tell us what value to use for the n, and we could plug the value in for n and figure out the numeric value of this expression. Well, by simplifying it down to this guy, you'll get exactly the same answer if you plug that value of n in here, but it's a lot easier to get that final answer now because you've done a lot of the, well, all the combining that you could do up here. So if we want to substitute in, this one will be a lot quicker and give us exactly the same answer we got up here. That's one of the main reasons we combine like terms, but you'll be seeing plenty of other reasons as we go further on.